Alright, so I know I've got one big gap to talk about. Let me take a look at these notes that I typed. So, you want to determine if you're the first player. And how do you do that?
Did you create or open the shared memory?
Yeah, and then I kind of forced hand and said it'd be a little bit more graceful to make your first point of entry the semaphore instead of shared memory, since you're going to use that to force synchronization. So open semaphore with those flags, and that will succeed if you're the first player, and that'll fail if you're not the first player. I just had a vision. So if you are the first player, you would have succeeded with that. So if yes, then immediately some way to lock the semaphore. Now what will happen is if you're not the first player, you will do you could go ahead and open that up. You could do that. Somewhere in here, you're going to do some way to all right. So let me come back up here. You immediately you want to make sure that no one else jumps in there and starts messing with. So here, if you're not the first person, then you go, okay, I'm a subsequent person. I'm going to go ahead and, based on how it's written up there, probably let's do this. So if you're not the first person, you're going to try and obtain the lock. This person, if they're the first, they immediately lock it. Now you're going to read in the text file map. You're going to create the shared memory with SHM open. You're going to grow it using ftruncate. Then you're going to use mmap so that you no longer have to use file commands for reading and writing to the shared memory. Now you can use it like a character pointer and just as you would access a character array. And that in essence is what it is. It's an array of bytes that you're going to be flipping bits on, right? You're going to go ahead and you will either read this map text file a second time, or what I did is I read my map into a vector of strings so that when I hit here, I can then iterate through that vector, and for each string then represents a line of that map, and I'm simply checking if it's an asterisk. I'm going to flip that particular bit for that location in memory to gwall. Otherwise, ftruncate grows everything as zeros, so there's nothing to do. So it's either a wall or don't do anything. Then after that, you're going to drop the fool's gold and the real gold on there, and then you're going to drop the player bit. Okay. So let's reprise this. If you're not the first person, you go ahead and try and grab a lock. You go ahead and open it. Open the shared memory called mmap. We've got this is a bit that we haven't done yet, which is obtain rows and columns, because mmap is going to be one of the arguments to mmap is the number of bytes that you're mapping. So you need to know how large that map is, right? So I need to go back over how this is going to happen. You call mmap, and now you have to determine which player hasn't been taken yet. This particular process gets the free player bit. You drop that player in a random location. Now you can go ahead and release the semaphore because you're no longer writing to that shared memory. Again, that's the whole purpose of the semaphore, is you want to synchronize all the different player processes out there to ensure that only one process at a time is actually writing. Reading isn't an issue, but you want to ensure that only one is writing at a time to the shared memory so that you don't accidentally clobber each other. So then, at this point, it's for both players, or for all players. Then so you basically got some sort of if branch here for all that initial behavior. Once you go through either of those branches, then both players are going to fall into the same set of code where you just have a loop that's accepting keystrokes. And then consider with movement, you need to check that you aren't moving off the map, you're not moving into a wall, or you're only allowed to move off the map if you've obtained the gold. And be sure to wait, post around code that is modifying the shared memory. And you're modifying the shared memory when you're, for instance, moving your player. Yes?
So it says after opening for existing shared memory, we obtain the rows and columns. Is that something stored in the actual shared memory?
Right, so let's go back to that. I started to talk about that right at the end of class. So let me cover it in more detail and calmly. Okay, let's see. Actually, I didn't put it. Did I put anything here? All right, so let's take a look at, oops. All right. So on the initial pass of rationalizing the shared memory, we decided that it would hold just the array of bytes that comprise the binary form of the map. And that's what the different processes in the game are sharing. But we see that in the scenario, if you're not the first player, you assume that you do not have access to that text map. And so you need a way of learning what the dimensions of that map are. So now our shared memory takes on a role greater than simply holding the bytes that comprise the map, but it'll hold something more complex. It'll hold the bytes that comprise the map, but it also needs to hold the rows and the columns. So I started to propose that what that shared memory will be is not simply an array of unsigned characters, but actually a structure, where part of that structure is that array of unsigned characters. Okay? And we've got casting at our disposal, so we can make this shared memory be whatever we want it to be, right? You could, let's just look at a totally random example that doesn't have anything to do with anything. I could make the shared memory map to a floating point variable, or an array of floating point variables, right? So the shared memory we interact with as a file. Who cares what the hell you put in the file? You use mmap, same idea. We're going to get a pointer to so that we can manipulate it as if it's main memory, and we can say that that memory is whatever kind of thing we want it to be. So it can be an array of characters, it can be an array of floats, it can be a structure, or a pointer to a structure, right? We're dealing with pointers all throughout. So mmap returns a pointer to wherever this memory is. So the structure that I started to do up here, we've got rows and columns, and I added this. I think this is a nice, easy way of determining the players that are on the board. And it's just simply one byte that's 0 to begin with, and then the first player is going to flip their G_PLR0 bit of this byte. And then you just simply interrogate that thing and you march through. Is the PLR0 bit flipped? Is the PLR1 bit flipped? PLR2 bit? As soon as you find a free one, then that process is assigned to that player, right? And then you have a little bit of error checking. What you do is you see if all 5 bits are flipped, then you print an error message saying, sorry, can't have more than 5 players, and then that process just exits. So how you access that. Now, I haven't talked about the map itself. I'll talk about that in just a moment. So it would look something like this. And then accessing it, oh, this is incorrect. That should be an arrow, right, since it's a pointer. So here I am turning on the PLR0 bit. If you're trying to find which player is available, then you would have something like if bitboard arrow player and G PLR0 there is playing. So maybe I want to negate it. If this one isn't taken, then I'll make the process take this player. So you have a sequence of if statements, right? All right. So let me... Okay. I almost always lose my recording when I do that. I think I want to draw a picture. Yes.
So you see that we call mmap if it's the first player and also if it's the subsequent player. So mmap, that is something which is provided to the process. It doesn't. It's not actually applied to the actual shared memory. It's something only which is in the process, not in the shared memory itself. It's map. Every process calls mmap.
Yes, that's correct. mmap, just like if you want to print something to the screen, every process has to use cout. If you want to map the file descriptor that points to shared memory, then you use mmap. It's a per process thing, right?
So I think that mmap doesn't actually do anything to the shared memory itself.
It doesn't change it. It just enables a different kind of access to it for that process. All right. Let's see. There we go. All right. So let me pause a moment and talk about. Let me see, how can I get both of these going? Let me come down here. I don't think I want that. Oops, that's not right. Let me bring these design notes up. All right. If you're not the first player, obtain rows and columns. So whether or not so if you're not the first player, then the question is, how do you get these two variables? Let me see. At this point, I'm cramming all sorts of notes into this, so I wouldn't. I probably got both first player and subsequent player here in this code. Let me do this. Let me grab these. Let's see. Let me grab this, and let me grab these two. If not first player, you're going to do that because you know the name of the shared memory. You are going to not have those two. And I have to do a man page on SHM open to look at its expected number of arguments. So it's going to want the mode, even though that's irrelevant if I'm not creating it. So I'm just going to put 0 here. All right. So I've got this file descriptor. I'm going to bring a copy of this down, 12 through 16 or 17 yank. I'll put it here for reference. So I know that the first few bytes are going to be that, and I know the next bytes are going to be that, right? Here's the question. How at a system level can I read in an integer given a file descriptor? Read. Okay. Read. I'll buy that. Let me go ahead and bring this open here. Here's the system call for read.
Pointer.
So what's the first argument?
File descriptor.
So that's SHMFD. What's the second argument?
Pointer to the memory location you're writing to, reading or into.
Oh, all right. Yeah? There's no need to increment it, right? If you're reading from a file and you read 4 bytes, then your file pointer is moving automatically, so you can just keep reading, just like you'd normally read from a file. There you go. Once you have that, you can go ahead and do your mmap, and then the rest of it you can access normally. Okay.
What about the player?
So then then after that you figure out, so determine which player to be, and that's where you have that code that I started to do up above. Let's see, where is that? It would be 49. So if not that, let me see, I called it, looks like I used plural on my structure description on line 102. Of course, you can call this stuff whatever you want. Oops. So if it's, then I would say, so you'd have some sort of variable which would be the current player or the player ID, right? Every process would have a variable called player ID. However you organize your code, you need a variable for it. And then you would say, you'd also then have to say bitboard players, or, yeah, that's right, if this, I have this negated. So if this one isn't,
That setting player 1 for
yes.
player 0. And this, I'm just confused about the structure of this because it looks like this is happening if not the first player.
That's right. But what could have happened is I could have had the first, second, third player join, and then the first player quit. And now G underscore PLR 0 bit is free and available. Yeah.
It seems that how we accessing the player, we're assuming that it's stored in the first 8 bits, so it would be little endian. What would, if we do big endian, then you would have to skip 3 bytes and then read the unsigned chart players.
No, the data structure, as long as I go to 111, if I create a structure, you don't have to worry about whether it's big endian or little endian. You're just accessing it through a structure. As long as you're consistent, as long as you wrote it through the structure, you can read it from the structure. You don't have to do any big little...
I'm thinking about the padding between those ints and the character.
Yes, but that's handled internally. That isn't your concern. Right? All right. So that takes us to everything except this. What's your intuition? Give me your intuition.
An array, probably array of bytes being declared over here.
Unsigned char.
No.
Let's look at this first. Let's look at that. I think that's a good first pass. So what this does, yeah, that's what I want. Oh, let's see. Let's do this thing. How do I hate having to learn this. I want to scroll down. Why won't it let me scroll it down? Oh, wait. I just want it. All right. So, no. Stop.
I just have the idea that we have a huge chunk of shared memory, and if we're mapping it to character pointer, that character pointer will only grab the first 4 or 8 bytes, and the rest of the large chunk of shared memory you have to point it like to the next byte or something. It would be a bit messy.
Hang on, I've got to see if Let me see if by some miracle my old software is going to work nicely. No. Oh, yeah, you see, here's my problem, is this works, but I no longer have my menus, so I don't have any way of saving it or rescaling it or whatever. So, all right. That's all right. So here, this is this is our rows. Ooh, ABC. Rows, and I want that much larger. And you can even stick it in there. Of course, it wants to snap to the grid. How do I? There we go. That's rows. I can copy paste. This is columns. So those are integers. And then we had the one byte. So if I assume these are bytes, then obviously these are too small for a 64-bit machine, but that's all right. This here is our player's byte. And then I've got this pointer called map. And this thing wants to point to something. So maybe it wants to point to, do this. Maybe it wants to point to right there. So this isn't quite what we want, right? What we want is we want rows, columns, players, and we could make this work. So what you would do is you'd take the size of this structure and then you would add the rows times the columns, right? So you'd have it start here, rows times columns, and then you would have to initialize this pointer to point to this memory location, basically just past the address of map. But it's kind of kludgy. It's not great. We would prefer that map simply be pointing, be a label, if you will, that's pointing right there. Yeah?
But it seems that there will be padding, not padding or there, especially since the pointer is.
Well, yeah. Okay, so probably that there's some padding to get things on word boundaries, so this isn't necessarily just a single character. But for the sake of the discussion, it doesn't matter. I could go ahead and blow this out a little bit further. The same argument would apply. I would just simply have to move this chunk of the diagram over more to account for the padding, so it really doesn't affect the discussion.
I would also like to say that there's you can use offset of to determine exactly how many bytes a certain field is from the beginning of the structure. Offset of.
Right. So, but let's find a more graceful solution. So let's call this struct fun. Let's create our struct. Fun. Unsigned int rows. If you make it, whether you make it unsigned or not, that's really your discretion.
What would be the advantage of using unsigned versus
It definitely has an effect when you're flipping bits. As far the signed bit sometimes screws you up, but for the rows and columns, I think it's just emphasizing the obvious that you're going to have a negative number of rows and columns. I don't think it changes the implementation at all.
both?
Fun.cp. Oops. Where am I? Oh, struct fun. Right. All right, so 4 bytes, 4 bytes, 1 byte, 3 byte pad. Okay, so the pointer, that's just showing the space of the pointer. What if we do, let me try 4. So that's 4, 8, 12, and another 4 is 16. Let me bring this down to 3.
Oh, yes. For characters.
Now, what's happening is that this is going into the padding, right? 2. Oops. 1. So it actually turns out that line 7 on the left pane there doesn't take any space. So now it literally is this right here. It's a label that doesn't take any space, and it gives you the address basically at the end of that structure, which is exactly what we want.
So you can read easier, right?
So now, yeah, so now we don't have to deal with any of this funky extra pointer stuff. Let me throw players back in there since we need that. So this, when I go back to here, and I make this size 0, now I can simply do something like bitboard arrow map sub 0. That is the first byte of the map. Yeah.
And that first byte will be pointing to the memory location directly after the players. So it will be pointing.
It'll be
byte, so you can use it for something useful.
it's this byte right here,
Mhm.
right after players. Yeah. Okay. So that was a key piece of missing information right there. Now I'm pausing because I don't know if I have anything new to say. What questions do you have?
Did you already talk about the last player closing the?
Oh yeah, so when you quit, then what you have to do is you do the sem wait. You remove your bit from the player's part of the structure. You remove your bit from the map. And then you re-examine that player's member of the structure. And if that's 0, then you're the last player. And what you should do is you should you should unlink the semaphore and you should unlink the shared memory. All right. So let's come back to our notes here.
There's nothing else that a player would know where it is at any time. You just have to scan the map.
So that's up to you. That's an implementation detail that I'm leaving to you. There are a couple ways of doing it. You can do something like create a function that's like get player position, and you scan the map looking for that bit, right? The other option is you can actually keep 2 variables for the current player row and the current player column, or alternatively the current player offset, right, depending on how you want to do your conversion. So either way is fine. There is an argument to be said that it is inefficient to have to scan the memory every time to find the player bit. You know, computers are pretty fast at doing small loops, and those loops aren't very large, right? What are you going to have a map that's at most 1,000 characters or something like that? Computer's just going to whip through that quick, and it's certainly for this application, it's not undue overhead to do that every time.
It would be over though every single time.
It would be what?
Over you go.
Yes, but which isn't very large. All right. So let me see what we have here. If last player remove shared memory and remove, I guess I can say unlink. The second thing you should be doing is, remember I said you need to be doing error checking along the way. If something goes amiss, then you need to clean up any mess that you made as you exit out of the program. So for example, if you're the first player, you create the semaphore, you do the wait on the semaphore to grab it. Now you go and you create the shared memory, but let's say that SHM open returns an error. If so, for whatever reason, you're unable to create the shared memory. You use p-error to report the error, and then you need to unlink the shared memory the semaphore that you had created, right? Otherwise, if you just exit out, what happened was you created a semaphore and then you bailed out, and now it's sitting out there in the system.
The semaphore is sitting out there in the system,
Until you reboot.
and it got a lock on it, and no other process can get it.
Right. It would just create problems until that semaphore was removed manually or the machine was
So
rebooted.
basically, if a semaphore functions like a lock, if it only allows a certain process to access it, and if a semaphore sitting there, it thinks that there is a running process, where in fact there is not. So
Well, that's not an accurate statement. The semaphore doesn't think anything. It's just sitting out there for any process in the system to use. Your application is not going to function correctly if there's an errant semaphore out there. Right. It's unable to create shared memory. It bails out. You leave that semaphore sitting out there. Then if you ever try running the program again, that semaphore is already there. So, oh, there's already a player on the board, so I'm going to access shared memory, but there is no shared memory. And so it creates buggy applications. So you should be cleaning up. If there are errors in system calls, be sure before you exit out that you clean up any mess that you made. Other questions?
What would be the way to return a file string at the beginning of a file?
A way to return a what?
The file stream to the beginning of a file. So like
Oh, you mean to rewind the pointer?
Yeah. I
Uh,
looked it up on Stack Overflow, but the implementations they had didn't work for me.
there are these functions here, although these aren't working with, these are standard library file streams, not file descriptor.
No, yeah, with file streams. So I'm just, like, I read in the map.
Well, so you want a C style, what you want a C++ style stream, a C style stream, or a system file descriptor?
C++ style stream.
It would be, who here's taken 511 and can remind me of the call?
What?
It's seek either seek G or seek P.
Yeah.
So just do type C++ seek, doesn't matter which one. Seek G would be for input, seek P would be for output. So these calls will do it in C++.
I tried that, didn't work.
Well, so it depends. So here's the deal. If you tripped the end, did you trip the end of file flag before calling it? If you trip the end of file flag before calling it, you have to clear your flags before you're able to use any other member function on the stream class. So try it again, but insert a
Clear.
something .clear in there, whatever the name of your stream is, your stream object. And then it will work fine. What other questions you got?
So, returning back to the stock game board, our unsigned character area 0, it points to the area directly after the player.
Yes?
So, can you look at how we do the mmap size of game board?
That's
Plus-
it right here.
Yes, plus rows times the columns. So nice. So this is a mapping size of game board plus rows times columns, correct?
Starting at that arrow.
Mem.
That's where rows times columns begins.
But I'm mapping like size of game board, so this is the padding. Do we need to like
No, you don't. You ignore the padding. Pretend there's no padding. It'll work fine. Yeah.
Do our errors need to be formatted a certain way for grading?
No, I would. If it's a system call error, then I would use P error. Otherwise, I would use just C error, and then you can use exit to exit out. One thing I don't think I haven't talked about this. I don't have it as a grading criteria. Let's actually look at what I have. It's been long enough that I don't know what I have as a grading rubric at this point. One of the things I would like you to start doing, because it's just good practice at this stage in your career, is to be using the smart pointer facilities of the language, so shared pointer and unique pointer. This is going to help prevent memory leaks. So what you could do is, if you've got various things allocated dynamically and you're using these smart pointers, then when you exit the program, the destructors automatically run and the memory's automatically released, or when they go out of scope for that matter. So I'm just going to say that I would explore, if you haven't used shared pointer or unique pointer, take a little time, look at a tutorial. I'm not going to grade on it this project, but I may introduce it in a future project. What am I looking at here? Oops. This doesn't look right. Let me go to this. Looks like it's too late for you to turn in the project. Let me confirm that that's the case.
Just
Yes.
C doesn't have smart pointer. That's something in C++.
That's correct. It's a facility of C++. All right, so let me come back here. Let me edit this. Due date. Today's the 7th. We are, no, that's not right.
No, no. So,
That's a couple years old. That's my issue.
this is the double arrow years.
All right, you and your fancy knowledge. Okay, so today's the 7th. That makes sense. Let me say a week from now. That gives you the weekend, and then it gives you Tuesday to ask questions. Okay, and it really shouldn't take longer than that. But that means you gotta put in a real effort over the weekend, because if you kind of blow it off, you hit Tuesday night when you decide to crank on it, and you'll start hitting brick walls. So there's that. Let's see. I normally give a little bit of slop on it, so this would be the morning after is when the submit link cuts off. So it's due, hang on, that isn't quite right. What happens at the career fair?
Hopefully. Okay, so we have 3 holidays in one day. That's cool.
I like to think of the due date of these projects as a holiday. No, so it would actually be the night before Thursday's class, but the cutoff would be the morning of the class. So you could potentially stay up all night before submitting it. All right, so that's that. Rubric, that's why I originally came in here. Let's look at that. Does it compile? Does it run? Are you able to move through walls? Do you post a notice when you land on gold or fool? It should give you a message whether it's gold or fool's gold. That should be in the write-up. Do you post a notice when you leave the board after obtaining the gold, saying that you're the winner? Can you move all 4 directions using H, J, K, and L? When you move, are you calling draw map to make sure the screen is refreshed? Now remember that we don't have live refreshes for other players. It only refreshes when you move. But each time you move, it should refresh the screen. Are you managing shared memory correctly? Are you managing the semaphores correctly? Are you actually able to handle multiple players? If you got the other stuff going, you should be handling multiple players fine. So I don't have anything specific in here about error checking, but that would fall into the running. It isn't going to run correctly under all circumstances if you aren't doing your error handling. So you're going to want that. So that's what I'm grading on at this point. running correctly. Also make sure you don't have any memory leaks or any weirdness like that. Which, this one, I don't think there's really much of an issue with memory leaks in this one. It might be a bigger issue in the next one, but we'll just cross that bridge when we get to it. Any other questions? Got enough information to take a chop at it? All right, then what I'll do is I'll cut you loose a little bit early so that you can either start writing the code or go have an early lunch or whatever.